Welcome to Study Loop.
Okay, here's the circuit given in the question. Now, in this circuit, the total capacitance C equals to, since the capacitors are in series, so it's just the addition of the capacitors. So 15 plus 20 equals to 35 microfarads. This is the equivalent capacitance of the circuit. Similarly, the resistance are in series, so R equals to 30 plus 50. Now, this is equal to 80 ohms. Now, initially the voltage across the capacitance were given, and that was equal to 45 volts, right? Now, after a certain time, the voltage is reduced. So let me write that as V naught. So after a certain time, the voltage is reduced to V, and which is equal to 10 volt. So how long would it take from 45 to 10 volts? So since this is the case of discharging capacitor, so Q is equal to Q naught e to the power minus t by RC, where Q is the charge at any time t and Q naught is the maximum charge that can be there on the capacitor. Now since Q is equal to C into V, so let me write that as C into V equals to C times V naught to the power minus t by RC. Alright, so C gets cancelled out. This makes T equals to RC log E V naught upon V. Alright, so plug in the values of R as 80, C as 35 microfarads, and log E of V naught is equal to 45 and V equal to 10. This should give me time equals to 4.21 milliseconds. Okay, so this is the answer for part A of the question, right? Now let's do part B. What will be the current? Okay, it's pretty easy. Now the current I would be, the voltage across the capacitor is the same as the voltage across resistor, right? So VR, actually I is the current equals to VR upon R, right? Now VR is equal to VC, so I can write that as VC upon R. Now VC, voltage across the capacitor, is 10 volts. Now 10 volts upon what is the resistance total? 80. So this gives me 0.125 amperes. So this is the current that is flowing through the circuit at that time.